NFA is sometimes also known as NDFA. It is non-deterministic finite automata. In NFA or NDFA, for a particular input symbol, the machine can move to any combination of state, which means that the exact state cannot be determined. Hence, it is called the non-deterministic finite automata. It has a finite number of states, so it is a finite automata. And similar to DFA, there are 5 tuples in here. The first tuple is Q. It's the same as in DFA. It is a finite non-empty set of states which is denoted by either capital letters A through Z or with Q0, Q1. Second is sigma, which is finite non-empty set of inputs similar to DFA. It is also represented by small letters A through Z or with numbers 0 to 9. Similar to DFA, Q0 represents initial state and also denoted by in transition diagram with an arrow pointing to a circle or in transition table with an arrow pointing to the symbol. Similar to DFA, in NFA, QF represents final state or set of final states. There can be multiple final states which are represented in transition diagram by concentric circles and in transition table by either one circle or a star or a hash or a dollar and other symbols. Now the only place where NFA differs from DFA in tuples is the transition function. Now as said before that in NFA a transition can occur to any states. So instead of the what we did in DFA, where on any state if we have an input we went to other state, here instead of other state we can go to any combination of the other states. So it will be 2 to the power q. Since each state can either happen or non-happen, there are 2 chances for each state and the number of states is q, so we'll go 2 to the power q. Now this transition function is only for NFA in which epsilon is not involved. If we involve epsilon, the transition function will change to a transition function if on any state we give an input, along with that input we give epsilon, then we can go to any combination of the other state. If I were to give an example, it would be on Q0, if the input is 0, go to Q0, Q1. So we'll say on Q0, if the input is 0, we have to go to both Q1 and a self loop to Q0. Now since on one input 0 there are 2 transitions, so it is an NFA. An example of non-deterministic finite automata with epsilon would be, it would just involve an epsilon transition. So say on Q0, if there is an epsilon, then go to Q1, and on Q1 if the input is 1, then go to Q2. So we'll say Q0, there is an epsilon transition, we'll go to Q1, and on Q1 if there is 1, we'll go to Q2. Now since there is an epsilon transition, this would be NFA with epsilon. There is no epsilon in DFA. Thank you.